Welcome to the winter briefing for the winter of 2021-2022. I'm Travis Booth, a member of the Missoula National Weather Service climate team, and we'll begin the discussion on the La Nina conditions currently in place and the general outlook for the Northern Rockies winter. Dave Noble will then provide you with detailed analysis focused especially on the Northern Rockies. Additional supplemental information will also be available after the summary slide at the end of the presentation for those who want to dig even deeper into the data. And lastly, special thanks to team members Bob Nestor and Brian Conlon for their expert insight in bringing together this presentation. All right, let's jump in. As we look at the current sea surface temperature anomalies in the eastern equatorial Pacific Ocean, we see a substantial negative anomaly. These cooler than normal sea surface temperatures are indicative of La Nina conditions. The Climate Prediction Center forecast shows an 87% chance of these conditions continuing through the coming winter season, so a very high likelihood. A moderate strength La Nina is also most favored at this point. Lastly, one thing to keep in mind is that last winter had La Nina conditions as well. Another way of looking at this cold water anomaly is to look at how deep it goes. A strong reservoir of colder than normal water is observed currently with the ocean temperatures along the equator from 160 west to 100 west at a depth ranging from just below the surface to about 200 meters. This colder than average water supports further cooling over time as we enter the winter months in the equatorial Pacific Ocean. A multitude of dynamic and statistical forecast models are used to predict the sea surface temperatures in the eastern equatorial Pacific Ocean. The majority show anomalies of -5 to -1 degrees Celsius during the winter months, which would be indicative of a moderate La Nina condition. So what are the typical impacts to North America during the winter months with these La Nina conditions in place? Like we mentioned, a blocking ridge of high pressure can often be quite persistent over the northeastern Pacific Ocean, which causes the polar jet to dive into the Pacific Northwest. This leads to cooler and wetter than normal conditions in the Northern Rockies, with warmer and drier weather in the southern United States. Keep in mind, these are generalized conditions for La Nina winters, certainly not the weather pattern for the entire season. The Climate Prediction Center winter forecast is very similar to the pattern we just discussed in the sense of the impacts, with a trend toward cooler and wetter weather across the Northern Rockies. Forecasting this many months into the future can be quite difficult, as I'm sure you know. The forecast was similar for last winter, actually, cooler and wetter conditions anticipated for the Northern Rockies. So how did it turn out? The Northern Rockies had a late start, and as many of you were wondering in January, would the snow ever come? We did eventually have an active February, but the November through March temperature averages ended up being above normal across western Montana, below normal in north central Idaho, while the precipitation ended up being below normal over northwest Montana to slightly above normal over Idaho County.
Hi, my name is Dave Noble. I'm part of the climate team here at Missoula, and I'm going to finish the rest of the presentation. So let's compare the current ocean temperature anomaly with last fall. The colder sea surface temperatures along the equator from the dateline eastwards is the same, but the northeastern Pacific is different. There are cooler sea surface temperatures in the Gulf of Alaska and from Hawaii towards California. There is also a warm anomaly south of the Aleutians. This difference could help to enhance ridging over Alaska or the northeast Pacific in the next month or so. When looking for a similar match to the current ocean state, it appears 2010 on the right side seems very similar with respect to the warm and cool sea surface temperature anomalies in the northern Pacific. The Gulf of Alaska cold anomaly is similar, so is the trailing cold anomaly between Hawaii and California. There is a fair amount of subjectivity in trying to find a correlation, but could there be parts of the 2010-2011 La Nina that reappear this winter, such as more Arctic intrusions and above normal precipitation? It's worth watching. The current drought monitor places portions of north central Idaho and Lemhi County in an exceptional drought, while the remainder of western Montana is in a severe drought. The outlook through January of 2022 shows all of the Northern Rockies remaining in a drought, but with improvement. When you take all the La Niñas going back to the early 1950s and look at the departure from average in terms of precipitation, you get above average for much of the region. The temperature average for the past 20 La Niña December through February winter seasons have been cooler than normal. If you average the 10 back-to-back La Niñas since 1950, the average is a little bit colder than just looking at the past 20 La Niñas. This image, created by Brian Brettschneider, depicts the number of times that back-to-back La Niña winters were warmer than normal. Locations found near the Continental Divide had way less seasons that were warmer than normal. Both Mineral County in Montana and Clearwater County in Idaho had 8 out of the 16 back-to-back La Niñas that were above normal. One take-home from this image that depicts a count of how many times the back-to-back La Niñas were wetter than normal is that most places in the Northern Rockies had more than half that were wetter than normal. This is an interesting image to look at, as every La Niña season can be different. I personally would like to see a significantly more amount of La Niña cases than just the 16 here, to be able to get closer to findings that are statistically significant. The following 5 slides show the average monthly surface temperature departures and average jet stream configurations for all the back-to-back La Niñas. These are fun to look at, and I'm not trying to make any conclusions, just purely looking at the data. So here's November. On average, the temperatures were above normal and the jet stream was stronger with a deeper trough over the Northeast Pacific, and this pattern could bring a few westerly shower and wind events. If you're wondering about what may happen this November, the Climate Prediction Center is showing above normal precipitation and equal chances of above and below temperatures, except for a 33 to 40% chance for above normal temperatures from Grangeville east and south to Lemhi County. The latest long-range models, such as the GEFS and the CFS V2, are also depicting wetter than normal, which could help build snowpack in the mountains. I looked at which of the recent La Niñas had above normal snowfall at Pierce, Idaho, and found that last November they had 20 inches. Then in November of 2010, they saw a whopping 26 inches. It's kind of interesting. All right, let's go back to looking at historical data, specifically December averages for second-year La Niñas. December was slightly below normal, as seen in the black box, for much of the Northern Rockies, while the jet stream on average was northwesterly, which could bring possible cold waves and open the door for an Arctic air mass event. In January, the temperatures were below normal and the jet stream continued to be northwest, which could bring moist Pacific waves and give a potential for Arctic air mass intrusions. A very cold anomaly shows up to our north in February during the second-year La Niñas, and the average jet stream position continues to be northwest. The average of the second-year La Niñas for March was below normal. The jet stream average was westerly, which could keep it active potentially. The latest run of the long-range model CFS V2 is forecasting a stronger upper ridge over the Aleutians, extending south and east into the northeastern Pacific. This could mean the potential for Arctic intrusions with possible northwest waves that could bring the Pacific moisture needed for overrunning events. So this is for the December, January, and February, so the winter season. The CFS V2 is also predicting a wetter than average winter season, and it's on the fence for the temperature anomaly. Areas further north towards the Canadian border could have a higher chance for colder temperatures, while further south and west could be milder. Here we are looking at the percent of average of the snow water equivalent for different basins on April 1st following the most recent 7 second season La Niñas. The first image in the top left is from last season, just as an example, and it had a mixture of below to near average SWE across western Montana, while a few basins in north central Idaho were above average, shown by the light blue colors. Starting with 2018 and going back to 1972, on average, snowpack across the Northern Rockies was generally near to above normal. I chose to plot the percent of average based on the period of record instead of the 1981 to 2020 period because there were more basins that appeared in the plot using the NRCS plotting tool. Yellow equates to 70 to 89% of average, green 90 to 109% of average. The light blue colors equate to 110 to 129%, dark blue 130 to 149%, and the purple greater than or equal to 150%. In the following 15 slides, we'll take a closer look at snowfall, temperature, and precipitation at individual stations across north central Idaho and western Montana. Snowfall for Kalispell has certainly seen swings in the departure of normal for La Nina since the mid-70s. Last season came up short with only 40 inches. And the average for the November through March period is 51.6 inches. Before I go into this a little bit more, one caveat to Kalispell, well, the official station, which is at the Glacier Park International Airport, is that the airport is closer to Bad Rock Canyon, so it feels the stronger Arctic winds. And sometimes it can be tough to measure the snow, if it's blowing like 15 to 40 miles an hour. Those winds can cause, smaller snow accumulations. The winds can also kind of destroy the beautiful snowflakes, the stellar dendrites, and be chopped down to like small grains. But thanks to committed CoCoRaHS observers, we can now see how the snowfall can be drastically different away from the Arctic winds. Near the city of Kalispell and points west, one CoCoRaHS observer, located 1.7 miles northwest of Kalispell, saw almost a foot more of snow in both 2010 and 2017 seasons. A CoCoRaHS observer 2.5 miles west-northwest of the city of Kalispell reported 102 inches of snow in the 2017 to 2018 season, while the airport saw 81.5 inches. West Glacier snowfall was below normal last winter, with only 74.4 inches, but the preceding 4 La Nina winters were above normal. So I think confidence is fairly good that West Glacier in the surrounding region has a good shot at receiving more snowfall this season. The 2008 to 2009 was a back-to-back weak La Nina winter where the snowfall was below normal, and the most recent moderate to strong La Ninas were above normal. Missoula is on the fence on which way the snowfall departure could go for our upcoming season. Looking at the snowfall for Missoula, out of the 17 moderate to strong La Ninas since the 50s, 11 seasons were above normal and 6 were below. Out of the 23 total La Ninas shown on the graph, 13 were above normal and 10 were below normal. For Orofino, Idaho, there has been a mixture of above and below normal snowfall in the last 2 decades. Last season ended up above due to much of the snow falling in February. One thing that the 1964, 71, 88, 07, 08, 2016 and 2017 seasons had in common was that the snowiest month was December, which aligns with the climatological average. Another interesting thing to note is the CoCoRaHS observer in Woodland, which is located 15 miles to the southeast of Orofino, at an elevation of 3,100 feet, has shown a lot more snow than Orofino in the last 5 La Nina seasons. Thank you to the Woodland CoCoRaHS observer for your dedication in taking measurements. Lastly, we don't have complete snowfall data for Grangeville, but several CoCoRaHS stations have popped up on the scene in the last decade or so. So last winter, 20 inches was reported there, 11 inches in 2017, and 29 inches in the 2016-2017 winter. Now, when the co-op was reporting in Grangeville, they reported 58 inches in the 2010 season and 15.8 inches in the 2000 season. For salmon, Idaho, it appears that some of the recent La Ninas since 2005 have been below normal. 2005 was a weak La Nina, 07 was strong, and both 2011 and 2017 were moderately strong La Ninas. I would surmise that in order for salmon to receive more snowfall, they would need that juxtaposition of Arctic air in place with moist-specific overrunning events, just like what happened in December of 2016. Salmon received 20 inches that month, and that is even with missing co-op data for 14 days of that month. So this is a great example why we need consistent climate data from our co-ops, so we can look at these metrics later and compare apples to apples. For average temperatures in Missoula, it appears that more often than not there are more warmer than normal seasons during moderate and strong La Ninas. Just like we mentioned about snowfall, Missoula is literally on the fence because much of western Montana is the battleground for how far west the Arctic air will travel. The last time Missoula had a colder than normal winter during a strong La Nina was the 2010-2011 season. For average temperatures for Kalispell, in a similar vein as Missoula, it appears that the winter season can end up being warmer than normal during the strong La Niñas. During the past moderately strong La Niñas, Kalispell saw 3 out of 5 seasons that were below normal. The most recent strong La Niña season, 2010 to 2011, was colder than normal. And the most recent moderate La Niña season that was warmer than normal was last season. For Butte, Montana, it appears that there is more of a correlation for the weaker La Niñas to be colder than normal. There have been a mixture of warm and cold anomalies for both strong and moderate La Niñas. The CPC and other long-range forecasts would suggest that this winter could lean colder than normal for Butte. In this graph, notice that I squeezed the y-axis values. The departure from normal is more of like -4 to +4, just to make the bars stand out better. For the Orofino area, it appears that there is a decent chance for colder than normal temperatures. For Salmon, Idaho, in the past moderate La Niña seasons, there were 3 out of 5 that were warmer than normal. Salmon could be on the fence this year for temperatures. It could go both ways. For Kalispell precipitation, out of the 5 moderate La Niñas, 2 of them had above normal precipitation, and 3 of them had below normal precipitation. Out of the 23 La Niñas shown here, 13 were above normal, and 10 were below normal for precipitation. For Missoula precipitation, out of the 5 moderate La Niñas, 2 of them had above normal precipitation, and 3 of them had below. Out of the 23 La Niñas shown here, 9 were above normal while 14 were below normal. For Butte precipitation, out of the 5 moderate La Niñas, 3 of them had above normal precipitation, and 2 of them had below normal. Out of the 23 La Niñas shown here since the early 50s, 13 were above normal and 10 were below normal. For Orofino precipitation, out of the 4 moderate La Niñas with data, 2 of them had above normal precipitation, 95 and 2011, and 2 of them had below normal precipitation, 1970 and also last season. Out of the 20 La Niñas shown here with data, 13 had above normal and 7 had below normal precipitation. So it seems like the odds are in favor for above normal precipitation for Orofino. Salmon precipitation, out of the 4 moderate La Niñas with data, 2 of them had above normal precipitation, 1970 and 1995, and 2 of them had below normal precipitation, 2011 and also last season. Out of the 20 La Niñas shown here with data, 13 of the 20 had above normal precipitation, 6 had below, and 1 was right at the normal precipitation. So in summary, La Niña conditions have developed. There is an 87% chance that it will continue through February, 57% chance of a moderate strength La Niña. Above normal precipitation and below normal temperatures are forecast for the Northern Rockies. And then we have higher confidence impacts to the Northern Rockies that include higher confidence we'll have above normal mountain snowpack, especially across north central Idaho into west central Montana. For valley precip and snowfall, it's leaning to be above normal. Valley temperatures are leaning below normal across northwest Montana, near to above normal across north central Idaho. It could go both ways for Lemhi County. And more Arctic systems than normal. For more information, you could go to these links. It may be easier to search for these in your favorite search engine rather than trying to copy the links from the video. As always, if you'd like further information, you can give us a call at 406-329-4840 or email us at nws.missoula@noaa.gov. The following slides are purely supplemental. We have presented the bulk of what we wanted to show you and what you need to know. So the following may be useful for some folks. And we're going to look at additional monthly snowpack data, temperature precip anomalies for the past 6 La Niña winters, kind of a bigger picture. And we'll detail high impact events from 2 La Niña seasons of 2017-2018 and 2011-2012. Definitely the 2017-2018 season was way more active than the 2011 season. The forecast right now as it stands for the upcoming 2021-2022 winter is for a moderately strong La Niña. This image depicts snowfall that can be well above average over the Clearwater and Bitterroot Mountains for strong La Niña years. The next 4 slides will show you the monthly snow water equivalent departure from the period of record average for all the basins. Generally, the red, orange, and yellow colors are below average. the green is near average, and the light to dark blues are above average. So last November, top left, showed below average for the middle salmon to South Fork of the Clearwaters and across northwest Montana, but near to above normal elsewhere. The recent two second season La Niñas of 2017 and 2011 were generally near to above normal. In November 2017, there was more water in the snowpack across southwest Montana, and in November 2011, there was higher SWE across northwest Montana. November 2008 was very low, 99 was below normal, but 84 was well above normal. As you can see, there is a lot of variability from one La Niña to the next. So this is looking at the SWE for December's. And last year we had a mixture of below normal to near normal. December 2017 had above normal, southwest Montana. December 2011 had a lot of greens, which is near normal. And then there were some yellows, which are below normal across north central Idaho and portions of from Glacier Park down to the lower Flathead. December 2008 had a mixture, more kind of below normal northwest and then above normal southwest. And December 99 was above normal across north central Idaho and near normal western Montana. December 84 was crazy, above normal. This past January 2021 was below average in most locations. There were higher amounts of snow water equivalent across western Montana and portions of the Clearwaters in 2018. Near average in 2012, but with some below over the southern Clearwater Mountains in Idaho and portions of Glacier Park, Whitefish Range, and Swan Range. In January 2009, it was below average across extreme northwest Montana, above average across the southern Clearwater Mountains and southwest Montana, and near average elsewhere. In January 2000, it was near average across western Montana, but above average over north central Idaho. Above average from north central Idaho to northwest Montana in 1985. February 2012, 2000, and 85 were near to above average. 2018 was above average in most places, and this past February was mixed, with above average in north central Idaho and below across northwest Montana. The next 6 slides will show the departure from normal of temperatures, left side, and precipitation, right side, for the past 6 La Niñas. The images were created by Brian Bretschneider. So last winter was near to above normal in terms of temperatures, with below normal precipitation over northwest Montana, but above average across north central Idaho. I annotated what the January phase of the Pacific Decadal Oscillation was on the graphic just for fun. It would be kind of complicated to explain exactly what that is, only that it's a measure of what the state of like the northern Pacific is currently in, like looking at the ocean temperatures. We haven't done any correlation studies here yet on the PDO at this office. The 2017-2018 La Niña was moderate in strength and was a second season or back-to-back La Niña after the 2016-2017 La Niña season. Temperatures were colder across Flathead County and along the Continental Divide, whilst precipitation was above normal in most areas except near normal for Lemhi County. 2016 and 2017 ended up being a weak La Niña, but temperatures were much colder across the region. Precipitation was generally near to above normal. Besides being a second consecutive La Niña, the moderately strong La Niña 2011-2012 winter season ended up above normal across western Montana in terms of temperatures, but near normal in north central Idaho. Precipitation was near normal, but below normal across northwest Montana and Lemhi County. In this depiction of the 2010-2011 winter, it's very apparent that there were multiple Arctic intrusions into the northern plains here by the colder than normal temperatures. Western Montana felt the effects of this by being below normal, but north central Idaho was generally near normal, and the precipitation was above normal. Here's another second season La Niña, and it was weak in intensity, the 2008 to 2009 winter. Northwest Montana saw colder than normal temperatures. Remainder of our region was near normal, generally speaking. Precipitation was above normal from Idaho County, north and east into west central and northwest Montana. Alright, now I'm going to go through the more significant weather events of the most recent second season La Niñas. So here's 2017 to 2018. The remainder of these slides are for informational purposes only. Sharing about these seasons does not mean that our upcoming season will be the same. But with that said, generally we find that there could be more Arctic intrusions, and sometimes we find a more active Pacific jet stream, and this could lead to periods of heavy precipitation, periods of freezing rain, and blowing and drifting snow at times. So November of 2017 generally had near to above average temperatures and above normal precipitation. The 2nd through the 4th of November caught many people off guard by how much heavy snow fell. The event was caused by a shortwave and Arctic air mass interaction. Trees near Bull Lake in Montana fell over from the weight of the snow. Severe driving conditions along US 93 near Flathead Lake, and rough travel along Interstate 90 from Missoula to Butte. Example snow amounts from that event included 14 inches at Lindbergh Lake, which is northwest of Seeley Lake. That location is very interesting because it's just downwind of the Mission Mountains and can receive a lot heavier precipitation thanks to the upslope effects. A foot of snow at Marion, up to 11 inches in Libby, Lookout Pass, 7 miles south of Butte and Ovando. As you can imagine, this Arctic air left its mark across western Montana, and when we had a few westerly events, freezing rain occurred on the 9th, 10th, and 16th. And lastly, a strong cold front brought high winds, mainly impacting the higher elevations, which probably caused some wind loading where the snow gets deposited on the leeward sides of the peaks. Peak wind gusts included 69 miles an hour at Point 6, 95 miles an hour at Logan Pass and Glacier National Park, and 53 miles an hour at an MDT station located north of Avon. You can pause this image if you'd like to look at the metrics for different stations around the Northern Rockies from that month. December 2017 ended up being cooler and wetter. It was relatively quiet up until December 18th when we had another heavy snowfall event that was induced by a tropical moisture connection and an Arctic air mass. Freezing rain was reported in Mineral County. There were power outages, slick roads, and skier-triggered avalanches in the Flathead Range. Snowfall amounts included 2.5 feet of snow at Lookout Pass, 28 inches West Glacier, Montana, and over a foot of snow at both Eureka and Seeley Lake, 9 to 18 inches Libby area, up to a foot in the Flathead Valley, 10 inches in Finn, Idaho, 4 to 6 inches in the Camas Prairie of Idaho, and 3 to 8 inches in the Mission Valley. Last but not least, we had a huge snowstorm that dumped feet of snow from December 28 through 29. It was another tropical overrunning Arctic event. There were severe driving conditions, emergency travel only in Lake County due to snow drifts. There was an avalanche in Powell County that partially buried the cab of a semi. There was freezing rain reported from Idaho to west central Montana, along and ahead of the Arctic cold front passage. As you can see in the image, up to 2 to 3 feet of snow fell in many locations. How about that 3 feet just east of Big Fork? January 2018 was milder with more rain than snow. Freezing rain event in the Kootenai Cabinet region, West Glacier region, and the lower Clark Fork region between the 5th and 6th. January 11 and 12 had a moist upper level warm front that brought heavy snow along the Idaho-Montana border. 2 feet of snow fell at Lookout Pass. 13 to 18 inches fell in the Seeley-Swan region. A foot of snow fell east of Lowell in Idaho, and combine that with rain and soggy ground caused snapped and uprooted trees along US 12. Another freezing rain event occurred across western Montana on the 18th, while a mudslide occurred near Orofino. February 2018 was a crazy month for weather events here. Besides, it was a cold and snowy one. I remember our office being swamped with issuing a plethora of warnings and advisories that month. There were at least 8 large events, with 4 of those having to do with Arctic air mass intrusions. The first event from the 3rd to the 5th caused a blizzard in the West Glacier region. Essex gusted to 55 miles an hour with single-digit temperatures, with 9 to 12 inches of snow. Freezing rain was reported in the Flathead Valley and east of Missoula. Blowing and drifting snow occurred along the divide in the Butte and Blackfoot region, where they saw 4 to 6 inches of snow. The second Arctic event happened between the 8th and 9th and caused icy roads, high winds with tree and pole damage, and power outages across northwest Montana. Freezing rain and blowing snow with low visibility from the Flathead and Mission Valleys and eastern Lincoln County, and a heavy snow band impacted the morning commute between Missoula and Lolo. The third Arctic intrusion on the 14th and 15th caused severe driving conditions from icy roads, moderate snow and gusty winds from the West Glacial region west of the Marion area, The fourth Arctic, between the 17th and 19th, brought 1 to 2 feet of snow across northwest Montana and higher elevations of Idaho and western Montana due to moist westerly flow moving over Arctic air. Snow changed to rain, then back to snow in west central Montana and caused icy roads. 2 feet of snow fell at Powell, Idaho. 8.7 inches in Pierce, 3 inches at Cottonwood, Idaho. Strong south winds combined with recent 8 inches of snow caused a period of blowing snow and reduced visibility in the Camas Prairie, Idaho on the 23rd and 24th. From February 24th to 25th, 2 feet plus of heavy snow fell at Lookout Pass and 16 inches in Haugen, which caused severe driving conditions, and 14 inches fell north of Noxon. On February 25th, high winds of 50 to 60 miles an hour caused severe drifting snow with reduced visibility that shut down roads for a period in the Grangeville and vicinity. A local remarked, "I have lived here on the prairie for almost 30 years, and this was in the top 5 worst." And to end the month, from the 24th to 26th, heavy upslope snow with 2 to 3 inch per hour rates occurred from Lowell to Lola Pass in Idaho. Over 2 feet of snow fell at Elk River, 1 to 1.5 feet just north of Orofino on the benches. Over a foot of snow at Lowell. Near 14 inches at both Pierce and Dixie. 11 inches at Cottonwood. Here's an interesting fact that West Glacier recorded 42.8 inches of snow that month, which is 26.8 inches above the average. And they saw 19 days of snowfall greater than a trace that month. March 2018 was cooler but drier than average. We only had one significant event, thankfully, after such a busy February. This was a strong southeast wind with snow falling that caused whiteout conditions on Highway 28 south of Leadore to Gilmore Summit in Lemhi County, Idaho. All right, now we're going to take a gander at the 2011 to 2012 La Nina season. November 2011 was cold and drier than average. There were around 6 events, with one of them being an Arctic intrusion. From the 4th to the 5th, heavy snow fell in the Butte and Blackfoot region. Northwest flow brought periods of heavy snow showers between the 12th and 15th, with the winter of snow 16 inches fell at Marion. Between the 16th and 18th, multiple waves brought heavy mountain snow with snow and freezing rain in some valleys. Heavy snow fell along the divide with the Arctic intrusion. 17 inches fell at Bull Lake, 13 inches in Trout Creek, 11 inches Huron, 5.4 inches in Headquarters, Idaho, 2 inches Kalispell, 0.4 Missoula, and only 0.3 in Grangeville. November 23rd to 24th was a strong mountain wind event. Trees fell on power lines with a power outage in Florence, Montana. 85 miles an hour Logan Pass, 74 miles an hour Garden Wall in Glacier Park, 69 miles an hour at High Camp, which is south of Grangeville, up on the mountainside. 46 miles an hour at Zonalite, which is northeast of Libby. November 25th, westerly wave brought snow showers with a few snow bands and gusty winds. One of the squalls brought 46 mile an hour winds to Missoula. On the 27th, it was a high wind event. Logan Pass had 95 miles an hour, 75 miles an hour in Stevensville, 57 miles an hour, 0.6. Over 50 mile an hour winds blew shingles off of a roof in Missoula. December 2011 was mild and drier. December 3 to 4, large upper ridge over the northeastern Pacific allowed for northerly waves and light snow amounts. And there was a north to south snow band that impacted the Missoula and Bitterroot valleys on the 4th. 5.5 inches fell at Georgetown Lake. From the 20th to the 21st, a British Columbia shortwave brought snow to the region. 7 inches in Phillipsburg, 6 inches in Evero, 5 in Ronan, 2 inches in Missoula. From the 28th to the 29th, strong and moist westerly jet stream brought high wind to the mountains. Camas Prairie, Idaho, Highway 200 near Thompson Falls with power lines knocked down, and also in the Missoula Bitterroot Valley. 1 to 2.5 inches of precipitation fell in the mountains. Heavy rainfall led to rock slides east of Libby. There were some strong winds too, 100 miles an hour at Logan Pass. The Mullen Pass ASOS, which is situated up there at 6,000 feet above the highway, recorded 59 miles an hour. 58 miles an hour in Grangeville, and 49 miles an hour in Stevensville. Lost Trail during that event got over a foot of snow. January 2012 was mild and wet. Unfortunately, there was an avalanche fatality of a snowmobiler in the Flint Creek Range east of Phillipsburg on the 1st. Light freezing rain in Troy and Noxon on the 3rd in Montana. On the 5th, there were strong winds with a cold front, 63 miles an hour in Stevensville. On the 10th, freezing rain along Highway 12 and the Bitterroot Valley, Missoula. 12 inches of heavy snow fell at Morais Pass due to an overrunning and slight Arctic intrusion. 15th through the 20th, active snow period with heavy mountain and valley snow with some freezing rain, thanks to two large troughs that dug southeast from Alaska, British Columbia, and with an Arctic intrusion. Dixie saw about 45 inches of snow. Huron had 35.8 inches, 34.5 inches at Headquarters, Idaho, 33 inches Haugen, 29 inches in Ovando, 19 inches Seeley Lake, 16 inches in Missoula, 14 inches Orofino, 7 inches in Kalispell, 4.5 inches in Grangeville, and nothing in Salmon. I remember that event. That was one of my first winters here, and there was definitely a subtropical tap that moved over the Arctic in place. January 21st, there was freezing rain, Lincoln, Sanders, Mineral, Flathead, Missoula counties in Montana. On the 25th, there were high winds, Missoula, Bitterroot valleys. Hamilton had 60 miles an hour with mature trees that uprooted. There was a shed that was blown 100 feet. The airport here in Missoula recorded 59 miles an hour. January 29th, there was freezing rain across northwest and west central Montana. February 2012 had average to above average temps and near average precipitation. Unfortunately, there were 3 avalanche related fatalities in the month of February in 2012. On the 1st, there was one from a skier 9 miles east of Creston. There was another one on the 20th due to a snowmobile in the Lost Johnny Creek drainage in the Swan Mountain Range. And then on the 25th, there was another snowmobile triggered avalanche fatality located at Skyline Creek south of Morais Pass. Probably one of the biggest events that month was from February 22nd through 25th. There was a very strong and moist jet that brought heavy mountain snow and high winds. Here in Missoula, we had sustained winds of 50 with gusts of 64 miles an hour. Trees and power lines went down in Missoula, 71 miles an hour north of Avon, 57 miles an hour in Marion. There were trees down with 9 buildings damaged in Superior, trees down near Kalispell. There was heavy rain in north central Idaho. Lookout Pass only received 17 inches from that event, 16 Lola Pass, 14 at Lost Trail Pass. March of 2012 had a mixture of above and below temperatures with above average precipitation. The 12th and 13th system, there was an upper level low off of the Washington coast with a strong jet. Surface low and cold front that brought damaging winds and brief heavy snowfall. Kyla had 69 mile an hour winds, and power lines were down Kalispell and Victor. Roof of a Hamilton Fairgrounds barn flew off and landed on a resident's house, crushing the roof. Tree fell on camper and trailer in Ronan. Grangeville had 55 mile an hour winds, and there was a peak gust of 48 at the Missoula airport. March 17 through 19, moist Pacific system brought heavy mountain snow to the West Glacier region, Bitterroot Mountains, Butte, Blackfoot, and Seeley Swan regions, Lemhi County. 19 inches fell at Georgetown Lake, 13 in Anaconda, 9 inches heavy snow in Leadore, Idaho. 9 inches fell in 3 hours in Ovando. Between the 20th and 22nd of March, a second moist Pacific system brought heavy snow to the mountains and across northwest Montana. 17 inches of snow fell at a co-op that's located 30 miles south of Libby, 13.5 inches in Headquarters, Idaho, and 12.5 inches in Haugen, which is east of Lookout Pass.